Hi, everyone. Welcome to Tech Talks. My name is Sean Kramer. I'm the Senior Director of Technical Services and Training here at Viking. And today I have with me Doug Myers, who's in business development for special hazards at Viking. Hi, Doug.
Hi, thanks for having me today.
We are going to talk about our Oxeo system a little bit today. So that's what Doug is here for to have a discussion on. And I guess to start out, when we talk about Oxeo, the best way to lead into this type of system that we offer is maybe kind of go through the history of, how we got to our Oxeo system. I mean, it all started with Halon many years ago, right, Doug?
It did. In 1993, as you know, Halon was banned, and when we were uh, was banned by the Montreal Protocol, and we also manufacturers started using inert gas systems to replace Halon back in 1993 until 1996, where FM200 evolved, and manufacturers started using the FM200 uh, clean agent as identified in NFK 2001.
So that's the HFC 227, right?
Correct, correct it. And then, as you might know, the AIM Act is kind of was really Congress and the EPA were really looking at stepping down, asking the manufacturers to step down production of any chemicals they make with HFCs. So unfortunately, the fire industry was impacted by that because of our HFC 227 and HF 225. And there's a string of other HFCs that are approved for fire suppression in NFPA 2001. So that being said, then everyone kind of migrated over to the um, FJ 5112 agent, and that end agent is sort of under fire for its chemical makeup, which contains potentially added per polyfluoride alkyl, which is we know in the foam business it's PFAS. So uh,
So you're seeing a lot of people moving away from the halocarbons and more towards inert gas as the option for their gas production system.
correct, yeah, it's a more environmentally friendly um, way to go. Because if you look at inert gases like argon and nitrogen and blends, IG55 and IG 541, these are all inert gases that are approved for fire suppression in NFPA 2001. And but they don't have any global warming potential. There's zero ozone depletion, so they're a more environmentally friendly option for our customers.
Are all those kind of interchangeable if they're specified one over the other as an option?
I've seen the engineering community, if there is a specification for a blend, they might look at what are the other options for refilling purposes. Um, so sometimes refilling blends like IG55 and UG541 are pretty tough, but to answer your question directly, they do the same thing. They pretty much the same design concentrations. They're lowering the oxygen level in the volume or the hazard, right? So they're
Right.
lowering the oxygen level. Right now, our oxygen level here is 21%, and our nitrogen is 79%. So what we're doing with those inert gases is we're lowering those oxygen levels um, to meet the fire extinguishment.
Sure, and there's different levels that you're designing to, right? Like you have what's called the no AL level, the low AL level, with those different percentages that you have for the different design concentrations, you have different requirements as well, right? For the different percentages that you're reducing the oxygen down to.
There's design concentrations that for class A, B, and C, and also class D fire applications. Uh, we utilized them with the halocarbons. We had certain design concentrations that we had to meet for each classification of fire. How much agent or you would need for a volume to extinguish.
Mhm.
So it's the same exact thing for inert gas systems. Um, for instance, if we wanted to reach the design concentration for a Class A or a Class C type fuel, we would be somewhere around a 39% design concentration for Class A to a 42% design concentration for Class C. All that means is that the number that you're going to plug into a software, and all the manufacturers have software, and they're going to plug in a flooding factor. And that's what it is. It's basically 43%. There's a flooding factor, 52% is a your low AL as a flooding factor. And we're just bringing that oxygen level down to a point where we could extinguish that fuel for that classification. Um, One of the things that you're trying to get to for most server rooms, telecom data centers, switch gear, we're somewhere between 39 and and uh, and 42% design concentration, which really, when you look at the oxygen level, it's about 10 to 12%. So,
Okay,
yeah.
great. So when we talk about wifey's Oxeo system, there's two different inert gases that could be used for it. So we have argon as a possible option, and then we have nitrogen as a possible option. Now we know nitrogen is used majority of the time, and argon's more of a niche application. But could you kind of elaborate on where argon might be used and where nitrogen might be used?
Sure,
Look
sure, absolutely. Yeah. Um, Nitrogen, it can be utilized from class A, B, and C fuels.
okay.
It's very effective. And that argon would be used for class D applications, which would be combustible metals like titanium, magnesium, um, aluminum, and zirconium. So these are, I've won up against a lot of tooling machines for magnesium and zirconium,
Okay.
dust collectors and 3D printers,
Oh,
which we see they're using titanium. So these are great applications for argon because argon's a single molecule atom and it doesn't react with anything on the element chart. So it's
sure.
not reactive. You don't want to put water or nitrogen or halocarbon gases or anything in that nature on it that has fuel application.
Understood. So when we're making this transition from the halocarbon agents to inert gas moving forward, with the halocarbon agents, your MK5112, HSP 227, we're dealing with a lot lower pressures, in most cases with those heating agents than we're dealing with, inert gas with a clean agent now. So what are some considerations that we have to take in for dealing with these higher pressures, such as is pressure venting a must with these systems?
It is. Um, in NFPA 2001, there's a requirement, Sean, for providing a pressure vent count, even for the halocarbons. It's in the standard. It says you have to provide the pressure vent count. And our software does provide an estimate for pressure venting based on the type of agent you're using, the volume that you're protecting. We're going to give you in square inches of pressure venting required. If you're using our metric system, it's going to give you square centimeters of pressure venting required.
Okay. So, in my past experience with the halocarbon agents, I remember that the most difficult part of these systems and getting them up and running was sealing the room in which they were located in. And with those, we were dealing with lower pressures. Now we're dealing with much higher pressures. What is it, 200 or 300 bar system that we're looking at?
Yes, it is.
So, what are some of the challenges that you face with the room ceiling that approach with the Oxeo Energon systems?
Well, Sean, what we found out was that the halocarbon gases, these rooms need to be sealed really tightly. Um, we had to use door sweeps and we had to make sure that your lighting penetrations were sealed, or put in hard lid ceilings,
Okay.
for, and you had to have dampers for uh, your uh, air supply. You might, yeah, I can remember some smaller rooms that I did. I had to put gaskets in my electrical outlets. It was really crazy. And smaller rooms that you had, the worse it was. So with inert gases, it's completely different. It's a completely different ballgame. You still want to do your due diligence, put in your door screws, make sure your room is sealed as best you can. But inert gases are great for leaky rooms. We just did a study here at Viking, and we found out that you can have at least like a 5% leakage, and you'll still be able to maintain because of the density of air, the density of nitrogen. You'd still be able to have your hold time be met very easily with nitrogen.
Is it always a 10-minute hold time that you're looking at?
It is a 12-minute hold time we're looking for, and we're seeing much greater hold times with nitrogen in these Class A and Class B and C applications.
Okay, so we have a special listing that goes or testing that we performed.
We did. If you look at the Viking website, under the Oxeo design, there's a white paper on hold times that we did with the nitrogen systems.
Wow, so that's got to make it a lot easier for the room ceiling because that was always the difficult part when dealing with NFPA 2000 systems.
Yeah.
Now, when I talk about NFPA 2001 systems, you were talking about how there's PFAS, FK5112 and everything, and kind of associating our Oxio system, calling it a clean agent. It kind of has a bad taste in some people's mouths because of what they're seeing with the halocarbon agents, but it's still a clean agent by definition in NFPA 2001, correct?
It is. It
Even
is.
though it's an inert gas, still
Yes. Actually, all the inert gases that we talked about, the IG01, IG100, IG55, which is a 50-50 blend of argon and nitrogen, IG541, which is a argon, nitrogen, and CO2 blend. They are all on the SNAP list. They're also all listed in NFPA 2001 as clean agents.
but the nice part is with these inert gases, with nitrogen, with argon, you never have a concern about one being not environmentally friendly. I mean, as you said, nitrogen's
Right,
what we're breathing in on a daily basis. So
right,
there's never going to be concern like, with halon that customers went through back in the day. And now that they're seeing where the halocarbon agents,
right.
you're never going to have that concern with inert gas.
There won't be any policies or restrictions on air that we breathe.
Yeah, I hope not. I mean, that would not be a good situation. So, uh, do the tanks have to be in the same room, for the areas that are being protected, or could they be located outside of the outside of the room? How far away can the tanks be?
Yeah, that's a good question. We get that question a lot from contractors because they're not sure if the tanks could be inside or outside. Even with the halocarbon systems back in the day, we um we told them that they can be inside or outside the rim. It doesn't matter. But the nice thing about the inert gases is you can really put them a long distance away. If you're a contractor or GC, or the owner doesn't want those tanks near the rooms that are protecting. Um, with our pressure reducer system, we can run that pipe a long ways at those pressures. This pressure's at 200 bar. That's 2,901 psi and 45th psi per 300 bar.
That's a lot of pressure.
So, right?
So you talk about a pressure reducing system. We have 2 different types of Oxeo systems that we offer.
Yes.
Can you elaborate on the 2 different types that we have and where you might use one over the other in certain
Sure, absolutely. So, we talked about the pressure reducer system, we're putting it remotely, uh, farther away from the, protected area, and, you're gonna use a pressure reducer, which is just a restricted orifice to step down that pressure from 200 bar, 300 bar to, less than 850 bar, on the other side, the downstream pipe, we call it.
Okay.
And the thing is the upstream pipe for pressure boosting has to be scheduled 160. But the downstream, and us manufacturers, we supply that. We don't want any contractors to make any mistakes. But the downstream side of it, the contractors can use Schedule 40 seamless. They're ASTM A53 grade A or B, or they can use A106 grade A, B, or C seamless pipe downstream Schedule 40 with Class 300 fittings. So when you look at the other system, you have the constant go, you can get some substantial cost savings on that pipe because you can use all Schedule 40 seamless pipe of the grades that I just mentioned
Yep.
throughout the entire system, the manifold, because we have the regulators that are before the check valve on the manifold.
Sure. So we're reducing it as the nitrogen that's coming out of the tank itself rather than after the manifold for the pipe downstream, allowing the Schedule 40 seamless pipe to be used on the manifold. Whereas with the pressure reducing, you have to use more heavy duty.
Contractors really like that because
Sure.
they can supply all the pipe and for the manifold and the downstream pipe.
So when we look at our Oxeo system, so we have the constant flow, we have pressure reducing. With a discharge, if you are protecting multiple areas with one system, they're all going to discharge at the same time in each of those areas. Are we working on something that would be a solution for that? If you have multiple areas that you would be able to only discharge in one area with only one system and kind of break it up depending upon where the fire's at?
Yeah, that's a great question. We do have what's called the multi-zone, the MZ1. It's the multi-zone system. And we're partnering with Fireflex, and we're going to be releasing the MZ1 cabinet. So look for that in the future. But until we do have that completed, that project completed, we do have the ability to, through panel logic, control modules, and your monitor modules and all that, to segregate the zones and have enough cylinders only for the largest zone. So for several projects, I know that you and I have both been involved with several projects where we had, 7 tanks for one zone and 4 for this zone and 3 for this zone. And we didn't need to buy tanks for every single zone. We just needed tanks for the largest zone. And we were able to use the selector valves and the multi-zone system to direct the agent to the zone that it needed and just amount of agent that that zone needs.
Great. Yeah. So how do you refill the tanks once they're discharged?
Well, uh, you're just refilling nitrogen or argon, depending on which one you're using. Our software gives you the ability to use one or the other for your applications, and you just need a CGA 680 fill adapter and you can take it to your local air glass in most cases. You might have another filling company in some of these local areas. It can do refills. They just need to be able to refill 2,900 psi or 4,350 psi. We have the fill charts, the temperature charts, and everything for in our manual.
Okay.
And all they have to do is refer to the manual for the fill charts, and you're able to do refills.
Okay. And yeah, you mentioned about uh for the pressure to fill them up and looking at the different requirements. Elevation is important to take into consideration when refilling one of these tanks. Is that correct?
It is your elevation, your temperature, and that's why we have the temperature curves.
Okay. Great. Um, what's your maintenance look like on these systems?
The maintenance is identical to what we did with the halocarbon systems. The maintenance is outlined in chapter 11, their maintenance and inspection of NFPA 2001. And it's identical to what we did before. You have your semi-annual inspections and your annual inspections. And of course, on your annual inspections, you're testing everything in that system just like you're commissioning it again.
So with the halocarbon agents in the past, your HF 27, that was stored pressurized as a liquid and was ready to transition into a vapor as it moves through the piping. Your FK512 was stored as a liquid, not under pressure, so it took a little bit more to transition. When we talk about the tanks and how many tanks are required to protect each of these areas, uh, does your inert gas require more tanks than, say, your FK512 system would? And if so, why does it require more?
Well, it depends on the system.
Okay.
Smaller systems, like would you quite a few 40-foot trailers, for instance, battery energy storage. And they'll probably use one tank of FK5112 or FM200 for that application. You'll use two tanks, 80-liter tanks at 2,900 psi for the same application. But our tank's footprint is 1 foot in diameter, so it's really not that big of a footprint.
Okay.
Uh, it does become an issue when you get into larger rooms and bigger data centers. The inert gases take up a larger footprint. Um, and that's why we migrated over to FM200 in 1996, was because of that footprint of the inert gas systems. Uh, but right now, it's a different time, Sean,
Mhm.
and we're looking at being more environmentally friendly and, zero ozone depletion and no cancer causing chemicals from man-made agents. It's a different time. So I've been talking to architects and engineers. There hasn't been too much resistance now. They're more afraid of the halocarbons and less, there's less worry about how many tanks we're going to use for specific project.
Right, the footprint
Yeah.
is not as much of a
It's
concern
not
as it
that
used
big a
to be.
deal, right?
Okay.
Yeah, and we don't have to put those tanks in the data center. But, well, one of the things you brought up, I will answer, is that you're going to use a lot less of FK5112 overall compared to the inert gas systems.
Which makes
And,
sense. It's just and also halon. We faced same thing with halon. Once we went from halon to the halocarbons, it was halon required those tanks as well. But there's reasons we moved away from both of them, and we are here, today why we're using these different types of systems. You keep mentioning data centers. Data centers are just popping up everywhere, not just here in the United States, but throughout the entire world. So gas suppression systems have always been a great option for data centers. Although sometimes now, some data centers, some of your smaller data centers are like 5,000 square foot. But we have data centers that exceed 10 million square foot. When you look at the largest data center today, so when you think about gas collection in data centers, what are some considerations that you need to take today when looking at a data center and determining what type of system to use, whether you're going with a pre-action system or whether you're looking at using Oxeo system for gas compression in that data center.
well, it's there's a lot to think about when you're looking at these data centers. These clean agent systems, after all, they are voluntary. The sprinkler system is not it's not voluntary.
Right. Your system's required by the building code where your clean agent system is your initial protection and you still require the sprinkler system as the primary system.
Right. And so for that reason, some of these larger, really big data centers, they're really looking at the pre-action systems as the first line of defense, the first option. And then, it just depends how much the downtime costs you. If the downtime is substantial, you just got to be break even or something. There's going to be something there a rip for. You got to do a risk analysis and see how much it's going to cost you to be down. Uh, and the other thing is, these data centers, they also had multiple backup places.
Yeah.
Right.
So it's not as much of a concern as it was, say, back in the 90s or even the early 2000s. But also, when we look at the cost of some of these racks, when you start talking about these AI server racks or these hyperscale data center server racks, you're talking about racks that could cost over $1 million per rack. So even though you're not faced with the downtime in these situations, that's a little bit scary to think about the damage that you could potentially do to the equipment when you get racks that are that expensive.
Right.
There's also uh, quantum computing out there that's coming around as well. I've heard some of those racks can cost $10 million each.
Right.
So I guess that's got to be another consideration is the cost of the equipment that
That's
you're
where
buying.
you have to do that risk analysis and see where you're at.
So when we talk about data centers and say we're using Oxeo system in a data center, w- what type of detection would you want to use for that application?
It's still using the same detection that we did with the halocarbon systems and the halon systems of yesterday. We're still using smoke detection. We still have pulsations and aborts. And the whole system works essentially the same way. We see a lot of very early warning detection with the air aspirating smoke detection systems. That's still specified largely by the specified engineers.
Which yeah, I feel that in a data center that your air aspirated detection has to be by far your best choice because most of your data centers are caused by overheating wires. So you get the little plastic jacket, starts emitting a little bit of smoke. You're going to catch it right away with an air aspirating detector. Whereas with a heat detector, you got to wait till you have a fire going that's actually going to heat up that detector and activate it. Would you agree with that? The air aspirating detection is
I
less
I
powerful.
will agree. It's you're gonna catch that fire in the incipient stage. So it's very early warning detection, like you said. We've had a lot of um, false discharges still because of other things that are going on in the data center. Contractors coming in and doing work and not notifying anybody and discharging systems because those things trigger really fast. And so what we've been uh, seeing the engineering community do is cross zone that very early warning detection system with spot type smoke detection. So
Okay.
that takes away the false alarm potential um, in a lot of cases, right?
Yeah, so they're using smoke detectors instead of heat detectors, so it's still gonna catch it, before you have a fully developed fire in the
Right,
place.
right.
Okay. Okay, that makes sense, alright.
So you're getting that early warning protection,
Mhm.
but we're not triggering the clean agent system until the spot detector picks it up, which is, it's not. It's gonna be a lot harder to set off as spots when detected.
So when we talk about Oxeo and, we talked about halocarbon agents, they're going away, halon, it's no longer in production, hasn't been for many years. Well, but when you look at an Oxeo system, could this potentially be a drop-in replacement for, say, a CO2 system?
No, it really can't.
Okay.
The type sizes are going to be much different. But when you look at total CO2, total flood systems, nitrogen could pretty much do anything a total flood CO2 system can do. And it's cleaner. It's better for the environment. So it is. It's something that the Vikings looking at and talking to our customers about replacing CO2 systems with nitrogen systems.
Great. So who else is involved in the installation of these systems? Who all would be involved? What type of contractor?
Wow, that's we want when the end user um, and the engineer get together and they specify a system, the general contractor is going to get the project and they're going to hire an alarm contractor or maybe a contractor that does both alarm and sprinkler, right? So they're
Sure.
we call them like a suppression contractor. And then your HVAC contractor needs to be involved for pressure venting. Yeah, so we want to make sure that all the trades are having that conversation together about in their weekly or monthly meetings that they're getting together and talking about the clean agent system and what trades need to be incorporated. So I find out that the the HVAC contractor is an integral part to the final commission because if there isn't pressure venting in an inert gas system, then we don't want to have that system commissioned.
Sure. So it sounds like there's a lot of coordination that has to go on between the different trades. So it's not just the one contractor coming in, doing the installation, doing everything themselves. There's got to be a lot of coordination throughout the project in order to make it work properly. Um, well, I thank you very much for your time, Doc. Please keep in mind that we have many experts here, like Doug at Viking, that are here and happy to answer any of your questions you might have about our Oxeo systems. We can help us in the design and provide guidance for these systems. Any training that you may need on these systems, we're always available to help. You can always reach out to our technical service department at techsvcs at vikingcorp.com or call our toll-free number at 877-384-5464. I thank you for your
Yeah.
time, Doug,
Thank you,
and
sir.
I thank
Appreciate it.
you all for listening to us today.
Yeah. Thank you.
Take care.